Welcome to the second video of the Safety and Etiquette portion of the Nanolab orientation. In this third section, we will focus on working with chemicals and how to do so as safely as possible, both for you and others around you. There are 10 safety showers and eye wash stations throughout the lab, with 5 on each floor. Each station has a safety shower, an eye wash, a privacy curtain, and an emergency response button, which we will discuss in more detail on the next slide. 5 of the 10 are designated as safety stations. In addition to the shower and eye wash, safety stations also have spill pads, a first aid kit, pH test strips and HF burn paste. 1 safety station on each floor has a defibrillator, and the others have a spill kit. Some stations also contain a safety cone, a dustpan to clean up broken wafer pieces, and an emergency contacts list. Please consult the CHP or Chemical Hygiene Plan to learn the locations of these and review them before starting work in the lab. There is a large yellow emergency response button located at each safety shower. This serves as a lab-wide paging system and will alert the lab if assistance is needed and the location that the button was pressed from. If you need help with a chemical exposure, please press this button. If you hear the page, please immediately go to the area specified and help the person in need, especially if it is during nights or weekends when less people are in the lab. Please note that this button is an emergency lab-wide paging system and is different from a fire or hazmat alarm. If there is a fire or hazardous material leak, there will be an audible alarm and flashing strobe lights throughout the lab, and the lab should be evacuated. If you hear the emergency response page, then assistance is needed at a specified location. In the event of a chemical exposure, please follow these steps. First, press the yellow button if assistance is needed. Remove affected clothing and rinse for 15 minutes using either the shower or eye wash, depending on the location of exposure. Please note that the deck hose of every sink is always on in case of a small localized exposure. If you suspect that you were exposed to hydrofluoric acid, or HF, follow the 15-minute rinse with an application of the calcium gluconate gel. The positive calcium ions will bond to and neutralize the negative fluorine ions. Finally, notify staff and follow up with a visit to a health center or eye doctor as needed. While proper precautions must be taken whenever working with chemicals, there are 2 chemicals that we stock in the nanolab that require additional safety precautions. One is hydrofluoric acid, or HF. If you are exposed to it, you might not notice immediately, but it can cause significant nerve damage and be fatal if untreated. Therefore, for any possible HF exposure, rinse for 15 minutes, followed by application of the calcium gluconate gel. The other chemical of particular concern is TMAH, or tetramethylammonium hydroxide. This is commonly used in photoresist developers in concentrations of approximately 3%. However, it is occasionally used in concentrations of 25%. Concentrations greater than 15% can disrupt nerve transmission, and exposure may cause respiratory or heart failure. There have been a few fatalities worldwide due to high concentration TEMA exposure. If you need to use the high concentration TEMA, first contact Nanolab staff to receive additional safety procedures. Staff will likely suggest alternative chemicals to try. If you need the high concentration TEMA, it is allowed only at one specific location in the nanolab. The nanolab stocks many chemicals available for use within the lab for all lab members. Chemicals may be stored in bins under the wet sinks or in chemical cabinets. If you need to transport chemicals within the lab, there are a few important rules to note. One is that you must always use secondary containment for transferring, such as a bottle carrier. If you need to transport chemicals between floors, you may never use the passenger elevator that goes between the gowning room and Bay 380. Instead, you may either use the stairwell or the chemical elevator. While we stock many chemicals in the lab, occasionally a lab member needs to use a chemical that we do not stock. The most common example is a specialized photoresist. In this case, please contact Nanolab staff for a procedure and permission to bring in your special chemical. This is not to be overly restrictive, but rather to ensure we know what chemicals are in the lab and how to safely store and dispose of them. Whenever you are working at a nanolab wet sink, you must wear personal protective equipment, or PPE. Even if you are just working with water, sinks are shared spaces and another lab member may be working with chemicals in a nearby space. The chemical PPE consists of a chemical-resistant apron, a face shield, and chemical-resistant gloves, and should go on in that order. Before putting the items on, please inspect them for any damage. Fill the gloves with air and make sure that none leaks out. Whenever you are done with the sink, you must remove your PPE in the following order. First, take off the gloves, then the face shield, and finally remove your apron. Even if you are returning to the sink, you must take off the PPE when you leave it. If you have trace amounts of chemicals on your gloves and you touch a door handle, and someone else touches that same door handle without chemical-resistant gloves, you expose them to that chemical and put them at risk. All nanolab sinks are certified annually as fume hoods. All chemical work must be done at the wet sinks, with the exceptions of acetone, isopropanol, or methanol in squeeze bottles. Prior to working with chemicals, be sure to know your chemicals and how to handle them safely. If you have any questions, stop and ask, and do not proceed until you're fully comfortable. There are some safety issues that come up frequently that you should know how to address. One is that HF etches glass, so never use a glass beaker with HF. Always use a Teflon beaker. Another is if you need to dilute an acid, always pour the water first and then add the acid to the water, not the water to the acid. When you combine water with acid, an exothermic reaction occurs, so starting with water and adding the acid reduces the hazard of this reaction. The exception allowed in the nanolab is piranha solution, where sulfuric acid is spiked with hydrogen peroxide, and the exothermic reaction aids in the removal of organic contamination. While the use of a hot plate can seem like standard procedure, hot plates do present significant safety hazards, especially when heating chemicals to high temperatures, with the potential of other lab members standing nearby. As a result, we have specific rules regarding hot plate use. Whenever using a hot plate, it must be labeled with a process ID tag. Solvents may only be heated in a water bath, not directly on the hot plate. Hot plates above 200 degrees Celsius require full supervision. You must stand next to your hot plate the entire time it is in use. Please consult the CHP for full details on hot plate use. Here, we'll observe the proper procedure for washing an empty chemical bottle. When you finish a bottle, you are responsible for cleaning it. While wearing all of your PPE, remove the cap and place the bottle upside down over the water spigot inside the bottle washer. Close the lid and press the button to start the water rinse. After 60 seconds, the water will automatically turn off. Use the provided terry towels to dry the outside of the bottle and replace the cap. Cross out the label of the bottle with a large X to let the custodial staff know that this bottle has been washed and is safe to handle. Place the clean bottle in the appropriate side of the recycling bin, depending on if it is glass or plastic. It is essential to know how to dispose of chemicals properly and safely, both for yourself and the environment. Acids, bases, and water-miscible solvents can be aspirated. The aspirator is a vacuum hose that sucks up the chemical and flushes it with water before taking it to the acid waste neutralization system that is located in the basement of the nanolab. Here, waste is treated according to guidelines and requirements set forth by the municipal district. Water-miscible solvents include acetone and isopropyl alcohol, as long as no photoresist is mixed in. If you are using organic waste, including photoresist and non-miscible solvents that are often used in the photolithography process, then these are disposed of using the organic waste disposal bottles located at many sinks throughout the lab. Specific training to use the organic waste bottles will take place during sink training. These chemicals should never be aspirated for environmental safety reasons, and acids may never go into these bottles for safety concerns. These are the two most common categories of chemical waste in the nanolab. There are also special cases, including gallium arsenide waste and acids with metal waste mixed in. If these cases apply to your process, please consult process staff prior to starting your process to determine the correct waste disposal procedure for you. After you finish processing, you must clean up after yourself. This can take different specific forms. Did you leave a spill at a sink? Be sure to clean that up. If it's water, it can simply be wiped up. If it's a chemical, dilute it with the deck hose before cleaning up. If you are throwing away garbage with organic waste on it, such as gloves or aluminum foil with photoresist on them, be sure to put them in the vented waste garbage can, not the regular one. This serves multiple purposes. It prevents lab members from breathing in fumes all day, and is also handled by EH&S for safe disposal. If you spill droplets of photoresist, these usually clean up easily with acetone, so long as you clean them up soon after spilling. Acetone can be found in red squirt bottles for ease of cleaning. In the next section, we will review additional safety information important to working in the nanolab. Never throw away a sharp object into a regular garbage can. These can easily poke through a garbage bag and injure the person carrying the bag. Instead, we have various disposal bins for sharps. If you have larger sharp objects, such as broken beakers, please dispose of these in a large yellow bin. There is one on each floor of the lab. If you have small sharp objects, such as a razor blade, scribe, or glass slide, please throw these away in the small red sharps bins that are found throughout the lab, often mounted to the side of a table or on the wall. If you have old wafers, please throw these away into the blue silicon scrap bins throughout the lab. Finally, the use of mercury thermometers is prohibited in the nanolab. If you accidentally use one, you may never throw it out in the lab garbage cans. Please call staff for proper and safe disposal. Many different kinds of metals are used in deposition processes in the lab. Some of these metal dusts can be toxic if inhaled. Therefore, when working with these, never use a nitrogen gun to blow off dust from your sample. Instead, use a HEPA vacuum to suck it up. When you are finished with your work, please wipe down all tabletop spaces and change your gloves. If you would like to bring in a new evaporation or sputter source, please contact staff first so we can ensure we know the proper procedures for handling the material safely. Unfortunately, a chemical spill or flood may occur. In the event of these, it is important to know how to handle the situation in terms of who to contact and how to start the cleanup yourself if you feel comfortable. If you see one of these situations, please contact staff immediately. If it is after hours, use the emergency contact information posted at every phone. If there is a chemical spill, please contain the spill using the spill containment kit available at safety stations while wearing all of your PPE. Final spill cleanup will be done by trained staff certified for spill cleanup. If there is a water leak, attempt to identify the source and turn it off. Use the squeegees and wet vacuum located near the freight elevators on each floor to start to remove the water from the flooded area. In the event of an emergency, such as a fire, please turn off the tool using the red emergency motor off or emergency power off buttons. Please note that these are hard stops to the tool and should not be done casually. If you load the wrong wafer, that is not an emergency, and pressing one of these buttons could bring the tool down for a significant amount of time. Never daisy chain power cords or make any electrical modifications yourself. Doing so is hazardous. We have a licensed electrician on staff. If you have a request, please come and talk to staff. We are here to help you, but you may not do this work yourself. Some users in the nanolab work with lasers or cryogens. It is important to understand the hazards of these and how to protect yourself. If you will be working with any laser equipment in the lab, be sure to have proper eyewear and to read all safety data beforehand. Contact our laser safety officer with any questions. If you will be working with cryogens, such as liquid nitrogen, be sure to wear cryogenically rated gloves and goggles to prevent freezing burns. Additionally, never go in an enclosed space, such as an elevator, to prevent asphyxiation. Please review the EH&S cryogen fact sheet prior to working with cryogens. In the nanolab, we have 5 radiation-producing machines and 1 radiation source. The 5 machines are 2 scanning electron microscopes, or SEMs, 2 electron beam writers, and 1 X-ray diffractometer, or XRD. The source is a polonium source using the Surface Charge Analyzer, or SCA. The University of California requires anyone working near these tools, which is any NanoLab member, to have read the UC Radiation Safety Guidelines for non-users. To pass the NanoLab safety test, you must have read these guidelines. The link to the document is available in the NanoLab's CHP, or Chemical Hygiene Plan. In the final section of this presentation, we will focus on etiquette. If all members follow these rules and behave considerately towards each other and towards the lab itself will run more smoothly and efficiently, helping everyone's work be accurately done in a timely manner. In the lab, we like to emphasize the golden rule, which is to treat others how you would like to be treated. Here, we modify the golden rule by saying, treat the lab how you would like others to treat the lab. Do those big and little things that you would want others around you to do. We like to emphasize that we are all lab members, not lab users. This implies that we are a community. Community members look out for one another, and though they might sometimes disagree, they do so in a respectful way, always communicating maturely with each other. We all must remember that the NanoLab is a shared space with hundreds of lab members. Do not leave your items blocking tabletops and prep spaces. These should be open and available for when someone needs to prepare their sample for a process. Once you become a lab member, you may request personal storage space within the lab. Additionally, never leave chairs blocking aisles or doors. Doing so can be a safety hazard. On the next few slides, we will review etiquette as it relates to tools such as reservations, enabling, and disabling. If you arrive at a tool and it's enabled, you may not disable another person, even if you have the reservation. You must first make an honest effort to contact the person, such as paging and emailing, and waiting a few minutes. For example, they may have needed to briefly step out of the lab to use the restroom. If you feel that you are justified in disabling someone from a tool, please contact staff first and discuss the situation with them. From the opposite perspective of the previous slide, please always remember to disable a tool when you're done with it. Some tools cost money, and lab members tend to be excellent in disabling those as soon as they've finished with them. Some tools cost nothing to use, but keeping it enabled when you're not using it is preventing another person from using it to get their work done. This is an excellent example of the golden rule. Enable and disable tools as you would want others to. Imagine that you kept checking on a tool all day and didn't use it because it was enabled, and it turned out someone just forgot to disable it, and this prevented you from getting your work done. Always disable tools when you're done with them. When you're done using a tool, please clean up around you. This could be drops of photoresist on the manual spinner, spills on a sink, or small pieces of tape or Technicloth that you used in your process. Take a few seconds when you're done and leave the area in an excellent condition for the next person. When making reservations, please be thoughtful and considerate of others. Do your best to make the reservation for the amount of time you actually need. You're expected to unload your sample and have the tool ready by the time the next reservation starts. Do not make them wait on you. Also, please don't make a bunch of reservations that you might not need just because you can. Doing so could prevent someone else from making a reservation that they do need. Once you reserve a tool, you have a hold on it for up to 15 minutes past your start time. After that, it's up for grabs, and anyone can enable the tool. You cannot claim priority because you had a reservation if you show up more than 15 minutes late. Though we all must try to do our best and make reservations for the amount of time that we need, unexpected situations do arise, and it's essential that we communicate promptly. In this example, my reservation is scheduled to end at 10:30 a.m., and Emily's is scheduled to start at that time. I realize that my SEM imaging is taking longer than expected for an urgent sample. As soon as I realize I'm running late, I will communicate with Emily and ask if I can borrow a little of her time. If the member you need to reach is in the lab, the best way to contact them is often by using the paging system. Alternatively, you can find email addresses in the Researcher Gallery link of Mercury Web. By not waiting until the last minute to ask, she can plan her work accordingly. She has every right to say no to my request because she may have an urgent deadline or need every minute of her reservation. However, if I communicate kindly and promptly, she may be more willing to help me out. If you treat other lab members with respect, they will be more likely to accommodate your requests. The next 2 slides deal with a gray area regarding reservations and enabled tools. It could happen that a person is using a tool without a reservation, and after they've already enabled it, another person makes a reservation for an upcoming time. When you enable a tool, Mercury Client will give you a heads up about upcoming reservations. But in this example, the reservation was made after the enable, so the person using the tool has no idea that it is reserved. It is difficult to say who has the right to the tool at that point, the person who has it reserved or the one who is using it. It is very important in this situation to communicate with each other. If one of you does not have an urgent need, please let the other person use the tool, even if you feel that you're in the right. After all, you'd hope they'd do the same in the opposite situation. If you both have urgent samples, come up with a compromise, such as one person finishing their current dataset and then releasing the tool to the other. This slide shows the same situation, but from the perspective of the person already using the tool, perhaps being surprised by a reservation when they were concentrating on their sample. A good way to avoid this situation from arising is by always reserving a tool when you need it, even if it's a rarely reserved tool. While we hope that you rarely have to cancel a reservation, these situations do arise. Perhaps you are feeling sick. Perhaps your wafer failed at the previous step. If this situation arises, please email all qualified users immediately and let them know your time is free, especially if it's a heavily used tool and your reservation is within the next 24 hours. This concludes the Safety and Etiquette section of the Nanolab's orientation. Thank you for taking the orientation class, and we look forward to working with you.